So more about vector basics. What I want to focus on in this video is how do we actually specify a vector? How do we say what a vector is? And there's actually two different ways to do it. So we need to know both of these ways because they're equally common, and we also have to know how to go back and forth between them. So in this video, let me introduce the different ways that you can specify a vector and how they're related to each other. So first of all, method number one, the method that I've been talking about a lot so far, is you can specify a vector's magnitude and a vector's direction. So a few details about that I want to be clear about. For the magnitude of a vector is always positive, or zero, I guess, but it can't be negative. The reason why is because the magnitude is actually the length of a vector. So just as the length of something can't be like -5 centimeters, that doesn't make any sense. What are you talking about? The length of something can't be negative. Likewise, it makes no sense to say the magnitude of a vector is negative because it's its length. So how can it be negative? So the magnitude of a vector is always positive no matter which way it points. And as we talked about in the previous video, the direction is normally specified as an angle counterclockwise from the positive x-axis. Okay, but there's another way to represent a vector. There's a second method, and the second method is equally good, equally powerful, actually more useful for most of what we're going to do in this class, and actually more familiar to you once you actually break it down to what it means. And the other method is called the component-based method. So in this method, we write down a vector by specifying its x component and its y component. The x component and the y component, so the x component is basically, well, I better start a new line here and explain this from scratch. So let's say that if you drew a coordinate system with the vector coming from the origin. Okay, let me do that just so you can see what I'm talking about. So, say there's my coordinate system. Let's have the vector go, say, this way. Okay, so there's a vector. Let's call it vector A. Okay, so you draw a coordinate system with the vector coming from the origin. We already talked about how the magnitude and direction of that vector, the magnitude would be the length of the arrow, and the direction would be that angle that it makes with the axes. So where are the x and y coordinates? The x component is basically the Cartesian x coordinate of the end of the vector. And likewise for the y component. So what I mean by that is, imagine now that you think of the end of the vector here as being a point in space. You make that a little bit neater. Imagine the end of the vector here as being a point in space. That point has an x and y coordinate. So if you drop down in this direction, we have the x coordinate, and if you go horizontally in this direction, we have the y coordinate. So this point, as you learned in some basic math class, this point here has an x and y coordinate. So that x and y coordinate, if the vector is starting from the origin, is the same as the x and y component of the vector. So in other words, you can specify the vector in one of two ways. You can either say how long is the vector and in which direction, or you can say how far is it in x and how far is it in y. Good example of that, I've been using this example of giving directions a lot of times in the videos so far. And I say, like, you know, an example is 2 miles east of here. Let me give a slightly more complicated example. Let's say that my directions are that something is, you know, 5 blocks away in a direction so many degrees north of east. So that's a little bit cumbersome, as you can see. But the way you would actually give someone directions to that location in reality is probably to say something like, go 3 blocks east, then go 4 blocks north. So let me draw that out. Go 3 blocks east, then go 4 blocks north, and it will get you to a certain point. If you draw the vector from where you started to where you ended up, that would correspond to a certain vector. So you can see how moving in the x direction and moving in the y direction then specifies a certain point. Drawing an arrow to that point specifies a certain vector. So for instance, with vector A over here, I could either tell you that vector A has, let me just clear a little bit of space here. Okay, so I could either tell you in representation number 1, I could tell you the length of the vector is a certain amount, which would be the magnitude of A, and I could tell you maybe that it makes a certain angle here. I'm not measuring the angle in the standard way, but that's okay. I tell you that there's a certain angle here. That's one way to specify the vector. So if you were like reconstructing that vector, you would say, okay, I want to be at this angle, and I would want to go this far, and then I'll get vector A. The other way of specifying the vector, then, oops, deleted that text, but that's okay. The other way of specifying the vector is to say, how far do you have to go here, and then how far do you have to go here to reach the end of the vector? And if you're rebuilding the vector in that fashion, then you go this far in this direction, this far in this direction, and then you draw a vector from the origin to the final location, and you end up with the same vector in both cases. So those are equally good ways to specify a vector. And importantly, not only are they equally good ways to specify a vector, they're also closely related to each other. So there's a whole method of relating the two representations to each other, and it's going to be incredibly common for us to go back and forth between those two representations as needed. But I'll save going back and forth between the representations for the next video.